In our today's lecture note, we will talk about the multiplication rule of trigonometric function. Basically, these rules are no new set of rules. We use the addition and subtraction properties of trigonometric functions to generate new algebraic relationships between the multiplication of the same or different trigonometric functions. So let's first talk about some of the formulas that we have seen in the addition and subtraction rules for trigonometric function. Remember, if I have sine of alpha plus beta, then that can be written as sine of alpha cosine of beta plus cosine of alpha sine of beta. Whereas if I have sine of alpha minus beta, then I can write it as sine of alpha cosine of beta minus sine of alpha cosine of beta, cosine of alpha sine of beta. So now if I look at these two formulas that we have written down and decide to add these two formulas, on the left hand side, I get sine of alpha plus beta, so the sum of the two angles and the sine ratio of that, added with sine of the difference of the two angles. And that on the right hand side is 2 times sine of alpha cosine of beta, because the other terms, they are going to cancel each other. They are the same terms, positive and negative, so when added, they will cancel each other. And that has given us a product of two trigonometric functions, sine and cosine, on the right hand side of this new formula. So what we will say, if you have sine of alpha plus beta, so the sum of the two angles taken the sine over, added with the difference of the two angles and taken the sine over, then that results in the product of the two trigonometric functions, sine of the first one and cosine of the second one, multiplied by 2. And that is the formula, first multiplication formula for trigonometric functions. As you can imagine, I will now like to do the same thing for my cosine sum and cosine difference formula. So let's try to go there. Think about the cosine formulas. First, think about cosine of alpha plus beta. So that is going to be cosine alpha cosine beta minus sine alpha sine beta, and then I do cosine of alpha minus beta, which is going to be cosine alpha cosine beta plus sine alpha sine beta. So it is pretty similar to the first example that we have done, and possibly you can imagine what I'm going to do. I'm going to add them. So the left hand side is going to be cosine of alpha plus beta plus cosine of alpha minus beta. And now look at the right hand side. You have the sine alpha sine beta term cancel, so I get 2 times cosine alpha cosine beta on the right hand side. That is my third formula for multiplication of trigonometric functions. So unlike the first one where I have multiplied a sine term with a cosine term, you have seen that in this formula you multiply 2 cosine terms. So what I will do a little variation of the last example. So I will still work with cosine alpha plus beta and cosine alpha minus beta, but this time I will start with cosine alpha minus beta, which we know is cosine alpha cosine beta plus sine alpha sine beta. Then I will write down cosine alpha plus beta, which will be cosine alpha cosine beta minus sine alpha sine beta. Instead of adding these two terms, I'm going to now subtract. So this becomes a minus, the minus becomes a plus, and what we will have on the left hand side, instead of having a plus of cosines, I will now have cosine of alpha minus beta minus cosine of alpha plus beta. And if I look at the right hand side, I can cancel the cosine terms, and I have 2 of the sine terms multiplied as 2 sine alpha sine beta. So these are the three multiplication formulas, and we will see a couple of examples involving these three formulas. So let's go to our actual lecture notes and try to work out problems. Okay, so the first example says, use the product to sum formula to find the exact value if 2 sine 52.5 degrees times sine 97.5 degrees is square root of 2 plus square root of a over 2, then what is a? Now, since the product is the product of two sine functions, I'm going to recognize the correct formula. And if you think of the third formula, that is a product of two sine functions. So that's the formula I'm using. So to remind myself, I'm going to first write down the formula. And the formula will be cosine of alpha minus beta minus cosine of alpha plus beta is equal to 2 sine alpha 2 and sine beta. And remember, we are trying to identify my alpha and beta with the third formula here. So what it tells me that my alpha must be of the form 52.5 degrees and beta must be of the form 97.5 degrees. So since the right hand side is given, we write the left hand side. So I get cosine of alpha minus beta, so 52.5 degrees minus 97.5 degrees minus cosine of alpha plus beta, so 52.5 degrees plus 97.5 degrees. Simplify both sums, so I get cosine of, the first one is negative 45 degrees, the second one is going to be 150 degrees. Now I know cosine is even, so cosine negative 45 degree will be equal to cosine 45 degree. Even though I'm going to show you how to do that using reference angles. And the second one will require me to do the reference angles. So let's go ahead and understand both of these angles in terms of reference angles. So remember, when we are working out these problems, we are going to first draw the angle in the standard position. So for negative 45 degrees, it will be in the fourth quadrant, so that is negative 45 degrees. So the reference angle, being the angle between the nearest direction of x-axis and the terminal side, and an acute angle, the reference angle is 45 degrees. It is in fourth quadrant where cosine is positive, so I just get cosine of 45 degrees. The second one is, of course, 150 degrees, so draw it first in the standard position. So that will be in the second quadrant. So this is the angle 150 degrees. Reference angle is the angle between the terminal side and the nearest direction of x-axis, and that's an acute angle. So this is going to be 30 degrees. But it's in second quadrant where cosine is negative. So I get minus of cosine 30 degrees. And I know the values of these two special trigonometric ratios. So I will say that the first one, cosine of 45 degrees, is square root of 2 over 2. Then I have minus times minus, so plus. Cosine of 30 degree is square root of 3 over 2. Since both denominators are 2, I already have the common denominator. So I write square root of 2 plus square root of 3 over 2. Identify that with the given form, and it clearly tells me that a must be equal to 3. And that answers my first question. The next one is a combination of cosine and sine in the product. So that reminds you of the first formula because that was a product of cosine and sine. So I'm going to write down the formula to start with. I will say that while the formula we are using this time is sine of alpha plus beta. And remember, I added sine of alpha minus beta, which has given us 2 sine of alpha cosine of beta. So if I compare that with our given formula, then my beta is 37.5 degrees and my alpha is 7.5 degrees. And also you see the left hand side of this problem is lacking the 2. So what I will do, I will first work out what will be sine alpha cosine beta without the 2. So let's divide both sides by 2. So I get sine of alpha plus beta plus sine of alpha minus beta all over 2 equal to what we wanted to have, which is sine alpha cosine beta. Okay, now we're going to write down the formula. So I will say, write it as sine of, remember first I need alpha, so 7.5 degrees plus 37.5 degrees plus sine of alpha minus beta, so 7.5 degrees minus 37.5 degrees. So what I get, I said this is equal to sine of, when I add them, the first one is 45 degrees, the second one is going to be sine of negative 30 degrees. Now sine is odd, so you can bring this minus out and call it minus sine 30 degree. Otherwise, draw the reference angles. So 45 degree, I don't have to do anything. It's already in the first quadrant and we know the value. For negative 30 degree, that should be in the fourth quadrant. So that is negative 30 degrees. Reference angle is going to be the angle between the nearest x-axis to the terminal side and acute angle. So that is 30 degrees. But it is in the fourth quadrant where sine is negative. So I would write it as sine 45 degrees minus sine of 30 degrees. I know the values. Sine of 45 degree is going to be square root of 2 over 2. Sine of 30 degrees is 1/2. So I get square root of 2 minus 1 over 2. And finally, we're going to remember that this entire sine alpha plus beta plus sine alpha minus beta was over 2 in my original formula. So remember, this was over 2 because we had to divide both sides by 2. So that is what going to describe the answer for us. So this is going to be over 2. So that will be over 2. This quantity will be over 2. And finally, this will be over 2. So that will be over 2, which is going to be square root of 2 minus 1 over 2. Remember, dividing by 2 means dividing by 2 over 1, which means multiplying by 1/2. So I get square root of 2 minus 1 all over 4. And then compare this answer with the given format. So 4 in the bottom matches with 4 in the bottom. And the term is square root of a minus b. So a must be 2 units and b must be 1 unit. And that would answer my question. Let's see what else we can do. Okay, so this problem tells me to find the value of a by using the sum to product formula if cosine 225 degree minus cosine 195 degree is square root of a over 2. Now remember, the formula where you have cosine minus cosine is cosine of alpha plus beta, or you can actually start by saying alpha minus beta because it is the third formula, minus cosine of alpha plus beta is equal to 2 sine alpha sine beta. We're going to work with this formula, but we see that in order to find these values at this point, what we will require first is identifying the angles alpha and beta. So let's work on that. First, we are going to find out how much is alpha. So we will say alpha minus beta is equal to 255 degrees as it appears in the problem, and alpha plus beta is 195 degrees. And then I am going to add these two quantities. So I will get 2 alpha is equal to, when I add these two, I get 5 plus 5 is 10. 5 plus 1 is 6 plus 9 is 15. 1 plus 2 is 3 plus 1 is 450 degrees. So dividing both sides by 2, I get alpha equal to 225 degrees. And I can use this value in either of those two equations for alpha minus beta or alpha plus beta. If I use alpha plus beta, I get 225 degrees, that's your alpha, plus beta equal to 195 degrees. So I can subtract 225 from both sides, and that will solve for beta. So I will get beta equal to negative 30 degrees. So formula tells me that cosine alpha minus beta minus cosine alpha plus beta should be equal to 2 times sine of alpha, and that is 225 degrees, times sine of beta, which is negative 30 degrees. Let's use the reference angle for both of these situations. 225 degree is going to be in the third quadrant, so that is 225 degrees. For reference angle, I pick the angle between the nearest x-axis and the terminal side, which is clearly 45 degrees. And it is in the third quadrant, and sine is negative there, so I will say this is 2 times negative sine 45 degrees. Negative 30 degree, whereas, is in the fourth quadrant, so that will be negative 30 degrees. Again, reference angle is the angle between the terminal side and the nearest direction of x-axis, which is 30 degrees. It is in fourth quadrant and sine is negative there too. So that's minus sine 30 degree. Or you could have used the odd function nature and bring this minus out. So I get 2 times negative square root of 2 over 2, that's sine of 45 degrees, and negative 1/2, that's sine of 30 degrees. So I can clearly cancel one of the 2's from the bottom and get minus times minus plus, so square root of 2 over 2 as my final answer. I have to match it with square root of a over 2, so a must be 2 units as the final answer to the question. The fourth problem in our work is going to be in terms of x. And this problem says, use the product to sum formula to fill in the blanks in the identity below. So you have sine and cosine products. Remember, I get sine and cosine products if I add sine alpha plus beta with sine alpha minus beta. So let's write down the formula. Sine alpha plus beta plus sine alpha minus beta is 2 sine alpha cosine beta. So what I have is sine alpha cosine beta, so I can divide both sides by 2 to give it the form of the problem. So that is, I get 1/2 sine of alpha plus beta plus sine of alpha minus beta, and I should put that inside a larger parenthesis because I've taken this 2 from the bottom and written it in the front as 1/2. So this is what I want, and I know what is alpha and beta. The alpha is 7x by the formula, the beta is 5x. So what I said this is equal to 1/2 sine of 7x plus 5x plus sine of 7x minus 5x. Well, this is 1/2 sine of 12x plus sine of 2x. And that kind of answered my question. So when I'm filling in the blanks, I will go ahead and say that the first blank is 1/2 sine 12x. The second blank is 2x. And would clearly answer my question. The last problem is sine x plus cosine x. And I want to write it as square root of 2 sine of x plus a pi. And then we're going to find the a, that is between 0 and 2. So what we would need to understand first, that in this problem, the sine x plus cosine x, I want to give it a form of a formula that looks like sine of x plus a pi. So let's try to understand what does that mean. So think about just the formula sine of a, or actually I should write x plus a pi, just the way it appears. This is the form I need. But I know the addition formula for sine, so what is that? It is going to be sine of x cosine of a times pi plus cosine of x sine of a times pi. So if you now look at the left hand side, you would understand that the left hand side of the given problem is just sine x, where I have this sine x, and plus cosine x, where I have the cosine x. So I need a value for cosine a pi and sine a pi in a way so that that matches my given equation. What do I mean by that? Think about the given problem one more time. It had a square root here. So I must get a square root here, and I must get a square root here. But the left hand side of the original given problem doesn't have these two square roots. So whatever value from cosine A pi I am expecting must cancel the square root of 2. And similarly, whatever value I am expecting from sine A pi must cancel the square root of 2. And remember, actually at pi over 4, both sine and cosine takes the value of square root of 2 over 2, which is also 1 over square root of 2. So if this cosine A pi were to be pi over 4, then I will get 1 over square root of 2 here, which will cancel the square root of 2. So what I get to do, I get to say that this is equal to square root of 2 times sine x times 1 over square root of 2. And remember, cosine A pi, I want it to be equal to 1 over square root of 2. In that situation, square root of 2 and square root of 2 cancels each other, and I just get sine x. And this is what I want on the left-hand side of the equation. Similarly, you can say that square root of 2 times cosine x times 1 over square root of 2. And again, think about the square root of 2 and square root of 2 cancelling each other, and me getting only cosine x, so plus cosine x. That's exactly the left-hand side. So think about one more time what we have done. This is the right-hand side. We started with the right-hand side, did a bunch of manipulation, and obtained the left-hand side. And I wanted to know how much is A. Well, now we kind of know how much is A, because both sine A pi should be 1 over square root of 2, and cosine A pi should be 1 over square root of 2. That happens when A is 1/4. Think about sine pi over 4. That is sine of 1 over 4 times pi. So my A must be 1 over 4. And this is what I wanted to know. What is the value of A so that it is between 0 and 2? And it gives me the equality between the left-hand side and the right-hand side. So we'll say that this is 1/4. And that would answer my question. So this was a very short section. It's just identification of the given problem with one of the 3 formulas of multiplication that we have obtained from the sum and difference formula. So keep working on the homework problems. There are not many of them. If you have questions, let me know.